Upon successful completion of this lesson, you will be able to compare various types of optical fiber and their suitability for different solutions, compare various types of connectors, and locate fiber cleaning procedures in the Standard Cleaning and Equipment Safety Practices Manual. There are two types of fiber used in telecommunication, multimode and single mode. The basic difference between the two is in the size of the core and corresponding light-carrying characteristics. The multimode fiber has a larger core relative to the cladding diameter compared to single-mode fiber. The size of a core in a multimode fiber ranges between 50 microns to 62.5 microns, depending on the type of fiber, while the core of single-mode fiber ranges between 8 to 10 microns. The cladding diameter is usually 125 microns for both types of fiber. The multimode fiber, as the name suggests, has more than one propagation mode, which, although they increase the light-carrying capacity of the fiber, lead to intermodal dispersion. This severely limits its information transmission capacity and reduces efficiency. Multimode fiber is generally cheaper and of a lower quality than single-mode fiber because the optics are more compromising. Because of the bandwidth limitations, multimode fiber is suitable only for short-distance applications, while single-mode fiber are suitable for long distances. The multimode fiber can support a bit rate of more than 500 MHz per kilometer, while single-mode fiber can support more than 100 terahertz per kilometer. In addition, the multimode fiber becomes less efficient as the distance increases. Multimode fibers are distinguished by their refractive index profile of core and cladding, or by their core cladding diameter size, or by the classification system determined by the ISO 11801 standard. Different fiber manufacturers create fibers that combine properties of these fiber types. Based on the refractive index profile of core and cladding, there are two types of multimode fibers, step index and graded index. The step index multimode fiber has a core and cladding with a uniform refractive index, but there is a difference in the refractive index of core and cladding. As a result, there is an abrupt change in the refractive index at the core cladding interface, or boundary. Light rays are reflected at this interface and are propagated along the fiber. However, the transmitted pulse spreads when it reaches the fiber end, as light rays travel at different paths and speeds in the fiber core. This intermodal dispersion limits the bandwidth or information carrying capacity of the fiber. On the other hand, the graded index multimode fiber has a core with a graded refractive index that decreases from the center outward, while the refractive index of the cladding remains uniform. The core's non-uniform refractive index reduces the intermodal dispersion, and therefore graded index fiber has a higher data rate bandwidth than step index fiber. Click Next to learn about the multimode fiber types by core cladding diameters and the bandwidth-defined ISO 11801 standard classification system. Multimode fibers are also described by their core and cladding diameters and by the classification system determined by the ISO 11801 standard. In terms of core and cladding diameters, there are two types of multimode fibers, the conventional one with the core size of 50 microns and a second one with 62.5 microns. The bandwidth-defined system determined by the ISO 11801 standard classifies multimode fibers into three types, OM1, OM2, and OM3. The 62.5 to 125 micron, or OM1, and conventional 50, 125 microns, or OM2, are typically used for premises applications, since they can be powered with LED transmitters and support applications ranging from Ethernet 10 megabit per second to Gigabit Ethernet 1 gigabit per second. The OM3 is laser optimized 62.5 to 125 micron multimode fiber, or LOMMF, that must be powered with optimized VC cells in an 850 micron transmission window. The OM3 multimode fibers can be used for LAN applications because they are capable of supporting a bandwidth of 10 gigabit Ethernet up to 550 meters. However, as the data rate goes up, the distance that rate can be transmitted goes down. Next, we'll discuss single-mode fibers that are more suitable for long-distance applications and support more bandwidth.
característica muito compradora. Olha o que aconteceu aqui. Então, eu queria ver. Quer pagar e você só quer ter 2 análises por semana, é só se tornar Smart Trader. Deixa eu passar aqui o ED rapidinho, que fica mais fácil. Tá? Vou passar um ED aqui que dura 1 minuto e 15, porque fica tudo muito bem explicado. São...
Mercado ESC de 20.000 igualado em 100,789.5.
Although there are various names used to describe different types of single-mode fiber, the ITU has defined standards that describe the geometrical properties and transmission properties of single-mode fiber optic cables. The 3 most common types of single-mode fibers used are non-dispersion shifted fiber or standard single-mode fiber, dispersion shifted fiber, and non-zero dispersion shifted fiber. Their respective ITU specifications are ITU G.652, ITU G.653, and ITU G.655. Roll over each type of fiber to see a detailed list of fiber types.